My name is Hatim Basir. I'm going to be talking about SaltStack for managing private production environments in Windows. There we go. So a little bit about me. I work at Eagle 7 Trading. I'm a systems automation engineer. We've been using Salt for a very long time. We started at one of the .14 or 15 release. And we mainly use Salt to manage our Windows software deployments. So it's a little different from, I guess, what most people use Salt for, provisioning their servers and configuring them. We actually use this mainly just to deploy our homegrown Windows software and configure that. Right? So a little bit about the challenges we came across. We had a lot of trouble with software distribution in Windows. You know, we run a lot of stuff there. We had problems with like version control and management, making sure that the software that we wanted was going to all the Windows servers. And since being Windows, you know, if you're in a mostly Windows environment, you can move things around really easily with like UNC paths and stuff like that. So it's like, you know, all of that automation always wasn't really necessary until you got more sophisticated with the way your applications were written. We had pipeline problems. We couldn't get really fast from code to all the way to distribute it onto one of our production servers. And lastly, we had problems with where everything was. There was just code literally all over the place. There was software all over the place. There was like little zips and binaries that were just not stored in normal paths, and everybody just kind of hand did whatever they did. And that's kind of where Salt came in. Those two being the most important for us. To add a little bit more challenge into this entire problem is we run almost all Windows. That has changed a little bit, so pretty much everything is Windows. Whereas all of our Windows boxes reside in separate colos that are all internal, and there is no internet anywhere within our infrastructure. So all of our Windows boxes I can't do like a pip install and get new packages or something like that. Right? So in the beginning, we had like a dev guy, and he writes some code. And then he tells the ops guy, hey, I got this new code. I compiled these binaries. I need you to run them on this server. And he's like, all right, I got this. Email me your code. And we're like, what? What? Email me your code? And that's like not exactly the best practices. I'm hoping you guys know that. So we chose Salt to kind of help us and facilitate us with all of these problems. You know, it's easy to use after you get it all set up. It costs us a lot less time and investment to get everything up there. And you know, it's easier to write in Python than it is to write in command line or PowerShell and actually get a normal response back. So does everybody have Salt in their own environments right now, or are you guys just kind of getting started with it? Just kind of get an idea. Does everybody already has Salt in their Windows and so on and so forth? So kind of mixture of both. I also really don't like group policy, but that's a personal preference. Some people like it, some people don't, but you can probably imagine the complications getting into group policy distributing your own software. It's, you always don't really know what you're going to get. So in the beginning, our initial Salt infrastructure looked kind of like this. We had our dev guy. He'd make some code, and he'd build it out to it would get stored on some Windows build server, and then he would request our ops guy. And we had our ops guy would sit there, and he would get this request, hey, I need to bump this version of this software. And he would sit on one of his machines, get the software, put it on a USB stick, put it in another machine, move it to a Salt repository, or the Salt binaries, or the Salt roots, oops, excuse me, and then he would luckily bump his versions and make his configuration changes in Git, and then have Salt push out the software where it needs to go. So, you know, we ran into some challenges there. The big blue line in the center, that's where our internet stops. So on this side, I get internet. On this side, I do not. Technically, this one machine right here also doesn't have internet. So That's the way, those are the weird problems we came across in our infrastructure. Why it was like that? It was a design decision before my time to not allow certain things happen within the development environment. So all of our developers couldn't collaborate as well as they could have. So a lot of the binaries were built in different manners that basically ops had to cobble together to make an application. And that's a little bit about what this is. So imagine a developer. He writes some framework. He makes exe, exe triangle, DLL circle, square plugin. And this is the framework that he built. So he, obviously being a good developer, he's going to reuse some code along the lines, and then he'll make it a little customizable so you can add more plugins to his code. Problem was, he couldn't see all of the code, and he couldn't compile against, he could not compile against all of it. He could only compile his little piece of it and build that little piece. So what, being in the ops side, we had to take each one of those pieces, cherry pick them together, and cobble together a full application suite. So this was our first response. We would say, okay, let's kind of templatize or compartmentalize. What are our common factors between all of the application suites that we have, and package them up in zips. So we'd make a triangle circle zip, a square zip, and an octagon zip. And then to make one full application, we would add those two zips together, uncompress them, push them out via Salt to our production server, uncompress it, drop it into the production directory, and then run that binary. So you can imagine what type of Salt states we had. If you guys use Salt and can you guys read that? Not really? No? That one does seem very blurry. Let me see if I can fix that. Is that better? That's better? All right, so we were doing some really weird things with Salt. I think this was just because of not only our immaturity, but because we didn't really understand all the capabilities of Salt itself. We were doing stuff like, let's put the version number of our zip inside of the state. Let's name our states by version number so then we can track them. Let's, uncompress a zip and put it to the place where we want it to go. That kind of breaks a lot of saltiness. It's not stateful. It's hard to manage. You end up with a plethora of states for various versions that are not really being used at all. So it makes distribution and version control really hard. So it's basically what we have here. So this piece was kind of what we were trying to get rid of. And there's no way to clean up all of the hand-packed zips, because since we're cherry-picking DLL files from individual build directories and then putting them together in our own zips that we then transfer via USB to our Salt server that would then distribute them, it became very hard to manage what zips are actually still being in use, what binaries are actually still being used. So our new solution, which is significantly better that we have in place right now, looks a little bit like this. We have our developers. They still write code. They still build it onto a Windows build machine. It gets released. Then they just make a request to our ops guy. Our ops guy says, OK. He goes into one file in one place, one configuration in Salt, bumps a couple versions, whatever versions of the packages that he needs, commits it to Git, and then does a Salt push. And that distributes the software across. The colors are really light here. Interesting. So for our deployments, these were the steps that we went through to kind of make all of our deployments for Windows a lot more stateful, a lot more salty. The first thing we did was we templatized all of our application suites. We took an individual application, made it into, these are the types of DLLs that we could possibly have in them. And then we added all of those things into one big Salt formula. Then we took all of our binaries, and instead of hand packaging them, we used an API to pull them directly off of the build servers. That way we can just drop them directly in from the build directly into Salt. The next thing we did was we pulled all of our versions into one place that we can manage from one file or one directory for that individual app for that deployment. We're using pillars in this case. And we got rid of all of the unzipping stuff. There was no reason to. We could build everything into a library, or we could build, all of our builds were already raw files anyways. And there was no reason to zip them up anymore. We could just pick the files we wanted with Salt, use whichever ones and target whichever ones we needed, and then compile, use the Salt formula to compile together the entire application suite that we needed for that particular build. And then the best part, well, at least my favorite part, is we got to enforce naming standards because all of our developers wanted to name their stuff in different ways and build it in really, really weird ways, which would end up going to really strange locations on the build server. How many guys use TFS or have used TFS before? One guy, two guys. So TFS is a little complicated to actually build to different to different places, and it's hard to manage stuff like that. So luckily we've moved to Team City now, so we can manage that stuff a little bit better. And because of the nature of our infrastructure, we had TFS, and it was very hard to tell developers to say, hey, move your code into a place where I can get it programmatically. So that's how we came up with, okay, we'll just make a standardized location for all of our developers to follow. They can do like a major, minor, whatever name they want to call their application, and then a release directory. So that way we can go and pull whatever we wanted. So we've solved a couple of these problems. We can now distribute software pretty well. We can have some sort of version control and management. We almost have a full continuous integration path. And we can now stop storing binaries in multiple places and store them in one place that Salt can control. So how we did this. A few of the prereqs that I was saying before was, use a build system that has an API that you can query. TeamCity, Jenkins, there's a few others. I'm not really familiar with all of them, but these are the two that we've used. The other thing is Windows binaries. How do you compile them? So a lot of places I've seen compile an MSI package using a package build with TFS or whatever because it comes for free almost. So when you do that, you lose the capability of being able to install multiple applications on one server. Now I can't build my app A, B, C, and install all three of them at the same time to one machine because MSIs just don't do that very well. I mean, you can definitely add in some command line arguments or prefixes, but it becomes really hard to manage them. So what we decided was don't package up anything. We'll package it up for you. So we make Salt package, pull the packages directly off the build, then it cherry picks whatever files it needs for that particular application suite based off of the pillar file, and then deploys it, just like a normal file. That gives us some nice statefulness, and we can do some cool things with it later on. So we created a custom pillar to do version tracking for us. You can use whatever flat file you wanted. We wanted to use a YAML file, so we used a YAML file. You can definitely put this into a database or something like that, or you can write your own, whatever you really feel like. It's kind of like a little bit more than a map, but a little bit less than like a full-blown database. And this is kind of how we got the pillar file into our Salt repo. Because we wanted our configurations and our Salt pillar that was tracking the versions and all of these things to live in the same repository, we used a Git hook to actually push all of our commits to another place that then our custom pillar would then go and read that location to find the pillar for that particular minion. It's a little weird, but it works for us, and it hasn't broken yet, so I think it's okay. But you can definitely solve it other ways. I mean, even coming here now, it's like I think I've solved it maybe a better way in the future. So this is what one of our custom pillar YAML files look like. So we have, oops. We can specify where we want to deploy the application with what version of whatever software. We can say what kind of plugins we want to add on to our software. And then we can also give it like cool little customization tags. So how the custom pillar is rendered, it looks kind of like this. You know, you go find the YAML file, you render a dict, and then you just return the whole thing. You do some data munging, and you know, you can customize that stuff, and then you'll get a pillar dictionary back. You know, you can also do some customization pieces, like a win cron. So the win cron will let you do scheduling directly on your Windows applications. So has anybody used like Windows Scheduler to schedule application starts? No, no, yes, sometimes, maybe. Does anybody use like segwin cron? No? So does anybody schedule any Windows apps at all, or does everybody just run services? Yeah. Basically what we wanted is, in our environment, we have a very fixed start and stop time for any one application, because all of our applications are, the hours are designated from like an exchange. So there's an exchange open and an exchange close. So our apps have to be up before exchange open and before exchange close. So we can do stuff like start at this time, stop at this time. We use the Salt's built-in functionality to Salt schedule tasks to basically give it a cron tag, just like a Linux app, and schedule an app start and schedule an app stop. If you're planning on using schedules in Windows, you kind of need to install these two packages onto your Salt minion. I'm not sure why they're not included with the minions, but they're not included by default since the last version I updated too. You would need a Python date util, and you'll need the cron iterator. Cron iterator will just iterate over your cron tag, so then you can give your Windows schedule a cron line, or a cron time slice. And the Python date util will actually just, you know, set it up as a date, so then you know what times everything is going to run. If you want to do it statefully, this is kind of how it looks. So in our environment, again, being outside of the internet, or inside without the internet, we set up our own PIP server. We tell it which place to get pip and where to install the stuff. And then we just tell it to install the package. So you also have to package up your own pip, your own PIP server, and your own packages for your environment, which is not too bad. I mean, there's a couple different Python libraries you can use. I think there's one actually called PIP Server or PIP Server. I'll have to double check on that. So kind of an example of how we render that template. This is like a short example of what one of our application deployment templates look like. So we just go through, we grab some hostname information, we grab some pillar data based for that particular application, and then we iterate over and we loop over how many instances of that particular app suite we want on this one particular server. We can then tell it, you know, stage here, actually get them from here, and add these little start scripts and so on and so forth. Oops. What the? There we go. So the start scripts for us is really important. What it got us was we were able to do a push path or a staging path with Salt, so we could deploy all of our binaries to one location while our application was still running. And then, on a restart, our start script was smart enough to know that this is the staging location, and this is the run path. Wherever our run path is, if the versions don't match up, pull the new versions from staging, download them, and then start up your application. So this gave us all the statefulness we wanted in Salt for Windows. It's great. Now our Windows app kind of acts like a Linux app. gets rid of our file blocking, gets rid of the non-statefulness of being able to push a binary, a running binary, to a Windows machine. So you would push one place, run from a different place. On startup, you'll check where you're running from, or check your staging. If you have a new version here, you download the new version, or you copy it in, you move it in, whatever you prefer, and then you run your application. So I can stage my version upgrades for my binaries hours and hours in advance. And in a time-sensitive environment, when we only have 15 minutes to be able to start to finish an upgrade, it's a really big thing to be able to stage everything in advance. Question? We wrote this start script in Python that runs a... Right, exactly. So since we control what binaries get deployed, we can also template out the start script to say, this is the binary you're going to start, right? Because at the end, it's just a Python file. So I can tell my Salt to push in one place, run from a different place, and guarantee that I always will get the version that I expected out there. Better, I can actually stage everything out hours in advance, double check my Windows server to make sure that the versions I expect to be there, the configurations I expect to be there, are in my staging path. So I can make sure everything is correct before I have 5 minutes before Exchange opens and like the trader's yelling at me and saying, hey dude, my app's not working, what's going on? Yeah, that happens all the time. Question? That is kind of the beauty of Salt, because the way we deployed, we split out the app stack into individual DLLs. And if you only have 2 DLLs in your app stack that are changing, if you're doing a file management layer on Salt in your Salt formula, then it'll only change those 2 files. So I kind of went over why this is good. It gets rid of file locking in Windows, and you get Salt statefulness into Windows. I'm going to ask questions now. Does anybody have any other questions? I don't know. We're good? Yes. Removable DLLs. Right. So in our staging directory, you can put, there's a cool function called like salt clean in basically anything in a file manager or file recurse, and it'll delete everything that's in your staging and then redeploy everything. So if you do something like that, you'll lose the granular level of being able to just only changing these pieces. But because you're not touching what's actually running, it doesn't really matter. Right? And this would work even if you're doing pretty big binaries. So even if you're moving hundreds of megs around, you can stage it off hours and hours in advance, make sure everything looks good, do hash checks or sums, whatever you need to do to make sure what you think is going to be there on startup. Yes? Yeah, I feel you. Mm-hmm. Yep. It has definitely gotten a lot better. I still remember times when we would update, we intentionally held back version updates because of problems, because the original Salt binaries, the installers were all packaged as exes, and you had to kind of wait for the Salt binaries to get released. That entire paradigm has changed with Salt being able to update itself using a pip repo. So you can actually update the Windows Salt minion using a pip install, which you could not do in previous previous versions. So that, I think, came in 2015-5, I think. So, I mean, it sounds like you're basically doing what we're basically doing. You're doing deployments for your own software somehow. And Salt can do it really well. You can also use Salt's Win repo. I don't know if anybody's looked into the Win repo as well. That'll do the MSI execution and installation, or exe executable and installation for you. So if your software is capable of being installed like that, then you could go that route. Then just store your binaries. How you get them out of TFS is kind of a problem you're going to have to solve. So what we were doing is we had our TFS builds to like a shared storage, and then we would, I basically wrote like a couple like scripts that would verify that where we think the build is where it is, and then take that build off of the build server after it's been like approved by QA, and then move it into our Salt repository. So this was on every single build. In the very beginning, we were using like a run deck job. Like, now we're using a run deck job, but in the very beginning, it was just like a little command line script that you would run with a version number, and then it would go find the stuff and move it into the right place. You've got it a little bit more sophisticated. You can automate it with like a run deck job, and then so on and so forth. Did that answer your question? Any other questions? Yes. We use it for in Windows or in Linux or whatever. In Windows specifically, we use it now to actually install kind of dependency software, like .NET packages and stuff like that. We actually leverage the Win repo for things like that, of that nature, because we know it's a one-off installation. We also use it to manage we have Python installations on our own servers, so we use it to manage that as well. And because it's outside of the internet, you can do pip installs from a local pip repository for that. We also use it to schedule all of our jobs, all of our running processes, which I mentioned before. So just for that, it's been a blessing. Being able to manage all of your Windows schedules for all of your applications in one place and have them version tracked through whatever Git repo or through your pillar files makes schedule management and release deployments much, much easier. So kind of answered your question? Yeah. From Salt? Not at the moment. So there was discussion about using it, but right now we have our own, like a WDS server basically, that just keeps hold of all of the updates for us, and then we schedule updates on a fixed interval for them. But that's also because of, again, the nature of the entire environment. We don't have access to the internet, so we have to grab updates in one place, store them, and then test them against our software suite, make sure the updates don't break anything, and then get them applied. So, a few tips. Mentioned before Git Server. Put all of your Salt states, templates, and stuff into a Git Server. We did this early on, and it has saved us many, many times. Set up a local PIP server. This will help you keep all of your Salt minions and all of your masters on the same version without, like, if you accidentally did a pip install Salt or something, you might upgrade to the latest when you really didn't want the latest. Yeah, there's definitely command line arguments for that, but it happens. Mistakes happen. You can fat finger stuff. Clean up your environment. Make sure you have nice, clean host names, nice, clean IP schemes, so on and so forth. It'll help you target your minions and your masters a lot a lot better. Run your root, run your master as root, run your minion as admin or root on Windows. Try not to use, if you're planning on running your Windows Salt service as a different user, it still needs to be at least a local admin on that Windows machine to actually be able to do some things. It also, if it's, like, so we have it set up so then we use a different user, and we had it so it would use, it would install automatically on build of the actual Windows image. So we ran into problems because Salt, the service, not the actual installation portion of it, but the service itself wouldn't pick up the new user space. So we would have some Salt minions running a system instead of the actual user, which would break some of our internal code. So just be careful if you're planning on changing the Salt service to move to a different user. You're going to have to restart it once or twice before it actually picks up the right user space. Run your masters in like a hot or a hot-cold configuration with failover. Some more tips. Don't push your binaries into like Git. That might cost a lot of money. And also don't symlink a lot of your builds. I see some of your TFS guys might decide, hey, why don't we just symlink our build server directly into our Salt roots and then we don't have to move anything. That works if you have a really small build chain. But if you have a very, very, very large build chain and you're storing a lot of binaries or you're not cleaning up all the old stuff, then your build server's probably got like thousands and thousands of builds on it. And that will just make your Salt base roots really, really big. I think when we did this to test it out, we were running like a master with 20 or 50 threads, and every single thread was hitting like a 250 megs of memory. A simple ping wouldn't come back from our environment after like 5 minutes. So just be careful about keeping your roots relatively clean and flat, otherwise it will slow down. Some other tips. I talked about a little bit about command line tricks if you're using Windows. The state output and the debug have been very, very helpful on the command line. You know, you can debug your minion and you debug your master from there. So it helps out just to be able to see what's actually getting there. You can also test your master or your pillar files or your pillar data directly on the command line. So if you're thinking about, hey, I'd like to try this new structure for my pillar data, you can pass it in as an argument on your Salt command line, and then it'll pick up that data, and then you can just test there without actually having to write all of the pieces between if you're doing any pillar migrations or pillar changing. And then last, like just some testing and coding. Use Vagrant as a Salt master, some internal nats. If there's this cool GitHub project called Box Cutter Windows, that's like a, I don't actually remember who's managing it, but it basically has a repository of all of the Windows ISOs that it then goes through and installs like a Vagrant machine almost, but it'll install a Windows VM on Oracle or Oracle VirtualBox or VMware, and it'll just kind of take care of that for you. It actually has Segwit installation and Salt installation built into it, so then you can almost do like a Vagrant up. It's like a make Windows image, and you can get a Windows image into a testing environment relatively quickly, as long as you have everything set up. Also use PyCharm. It's nice. But that's it. Any other questions? Oops. Yes. So our developers, you're talking about configurations for your applications or your Okay, so we actually tell them to, you can build, especially if you're writing a lot of .NET, it automatically builds the config directly into that release. And since we already cherry pick our DLLs out of there, we just ignore all the config files, and then we keep our own copies of what goes where for each environment. So that's how we kind of got around that problem, because the developer might only code for his particular space, but since you have to release, maybe you might have to release that package to 4 different spaces, you're going to run into those kinds of problems. Any other questions? That's all I got for you guys. Thanks for coming.